Welcome to Data Science Beginner Bingo. In this video, I'm going to walk you through this bingo board so you can accomplish these 24 actually, you get one free space, 24 specific tasks that will help you get yourself ready for data science. The first item we're going to look at is how to install Anaconda. At this point, you might be asking, what exactly is Anaconda? Anaconda is a distribution of Python. Long story short, Python comes in a variety of different flavors and distributions. You're at the beginning of your learning journey. You can explore other flavors and other versions later. Get the anaconda.org version. Go to anaconda.org, click the Download Anaconda button that you're going to find up here. Of course, you need to give it your email address. And then once you've submitted your email address, you'll be able to choose the appropriate version of Anaconda for your computer. Download that version of Anaconda for your computer. If you need some additional help, check the bingo card. I'll give you some resources there. Otherwise, follow the on-screen instructions. The next bingo square we're going to do is set up terminal and bash. This is slightly different for Windows and macOS computers. If you need some additional help on this, there are more in-depth videos specifically for the Windows and specifically for the macOS computer. If you are on a macOS computer, I want you to look at the upper right portion of your desktop. Find this magnifying glass, click on that, and when you have your spotlight search, type the word terminal, and you're going to have the terminal app, and then drag it to your dock at the bottom of your computer. Once you put the terminal in your dock, you're going to have access to it. The terminal is going to give you a command prompt where you can type commands to interact with your computer. Other bingo squares in this video are going to show you how to use this terminal, a very important tool for you as an aspiring data scientist. And then finally, if you're on a Windows computer, and if you have already installed the Anaconda distribution of Python that I showed you on another bingo square, you can go to your Start menu by clicking on the Start button. You're going to find that Start button right down here. Once you click on the Start button, then go to your keyboard and then search the word Anaconda prompt. Once again, it's going to be Anaconda space prompt. And then the search results are going to provide you access to a terminal where you can interact with your computer now using the command line. Other videos in this bingo card are going to show you how to use that terminal. Now that we've installed Anaconda, we've set up terminal, we're going to verify proper installation of both Python and Anaconda. To verify your installation of Anaconda, find your way to the bash, the terminal that I showed you how to do in another bingo square. And then when you have access to type commands, I'll want you to type conda list anaconda. When you press return on that, you're going to get output on the screen, which is going to show you the versions of Anaconda that you have on your computer. If you see an error message that doesn't look like this, that indicates you haven't yet installed Anaconda. Return to the bingo square that installs the full Anaconda distribution before proceeding with this bingo card. We can also check and verify our installation of Python at this point. At your terminal on Mac or Anaconda prompt on your PC, type the word Python and press return. You should see that you have installed Python because you will see a version number for Python here, and you're also going to see, once again, a version number for Anaconda. At this point, we are ready to start navigating our computer using the terminal, the bash, or the Anaconda prompt. If you are still in your Python prompt at this point from a previous video, you can exit by typing the word exit, open, close parentheses. And once you do, you're back out to your bash or terminal or Anaconda prompt. Now type the word clear, or sometimes it'll be CLS on some computers, but not mine. Clear is going to clear away all of the information in your terminal output. Now at this point, the goal was to navigate to our desktops folder and also navigate to our documents folder. What does that mean? Well, when you're working with the command line prompt in the terminal, bash, or Anaconda prompt, you are working in a given directory or folder on your computer. And when you open your terminal, you could be just about working anywhere on your entire computer. So to quickly get to your desktop, type cd space till. Now to find the till, you have to press the shift on the keyboard and then the key on the far upper left of your keyboard, typically near or below the escape key, is going to be your till. So press shift till to get that till signal, then use a slash and then type the word desk. And at this point, we're going to our desktop. We can use autocomplete. Most terminals will support this. So I will press tab on my computer. And now I've given the command to navigate to my desktop. I press return, and usually the prompt will change in order to indicate that you are working in your desktop. Not always. It'll be slightly different depending on which bash, terminal, or Anaconda prompt you are using. Now, if I want to jump over to my documents, you might have already guessed it. documents is going to be the command that navigates us over to our documents. The next bingo square we're going to look at now is how to list files in your desktop or documents folder. In this terminal, you can see I have already navigated to the desktop portion of my computer. And you can also see over here, I've included the files on my desktop so you can see them. If I want to see the files that are on my desktop or in the desktop folder, all I have to do is type ls here. Some computers, that's going to be dir instead of ls, but you can see I have the miscellaneous folder, which corresponds here, the demo.py file, which corresponds here, and the demo.txt file, which corresponds here. If I want to get a little bit better information, I can type ls-lhr, and those are going to be flags which tell the terminal to give me more information about my files. This tells me who owns the files, this tells me the size of the files, and it gives me other useful information. Once again, on some computers, that's going to be dir. Try dir if the ls did not work. If I want to list the files in my documents folder, I can do cd space /documents in order to navigate over to that documents folder. And then I can use the ls command. And when I do that, you see the mess of the files that I have located in my documents folder. We're going to be demonstrating mostly with the desktop from here on out to keep it simpler. 2 bingo squares, we're going to knock out creating a new directory or a new folder, and also creating a new file using the CLI commands. Once again, here we are at my terminal, already on my desktop, and you can see the files that are here on the desktop. I can create a new folder by typing mkdir and then the name of the new folder. In my case, I'm just going to say new folder and then press return. And when I do that, you can see that the new folder has been created here. If I want to create a text file that I can also work with later, I can type touch and then the name of my new file. I'll say new file.txt. You can use uppercase or lowercase in your file names. It doesn't really matter. When I press return on that, you can then see new file has been created out here on the desktop. If I want, I can edit that new file by right-clicking on it, going open with, and then text edit. And now here you can see my text file is empty because we only created the file. We didn't do anything else with it yet. Other bingo squares will teach you how to work with that text file once you create it. One more thing, just to connect this new material with previous material we've already covered, navigating folders. Now that I've created this new folder here, and we can also see that new folder in our file list, I can navigate into that new folder by trying cd space new folder and press return. And now I am inside my new folder. If I list the files in the new folder, we see nothing because there are no files in that folder yet. The next bingo square we'll cover now is how to save or log the results of your terminal output to a file. To demonstrate how to save or log the terminal output results to a file, I'm first going to go to my desktop. Now notice, I'm currently in my new folder, the new folder that I created here that is on my desktop. If I want to go back to the desktop, I know that the desktop is the parent folder of new folder. So basically, new folder is a folder that resides within the desktop folder. If I ever want to just return to the current parent folder, I can type cd space ... and that's going to tell terminal to navigate you to your parent folder. Now let's look at the ls command. I can do just the ls command base, or I can do ls-lhr, which is going to give me a little bit more information. It is often useful to be able to save the output of your commands for later reference. So for that, once again, I can type ls-lhr and then use the caret symbol or the greater than symbol, and then just give the name of the file. I'll just call it files.txt. And when we press return, we're going to see a new file on my desktop called files.txt. If I want to inspect that over here, I can open that with the text edit. And then of course we see the output of my file list. The next bingo card square we are going to explore is how to inspect a file with the cat command. Here I am once again at my desktop, and I have new file. I have files.txt that I created in a different bingo square. I'm going to clear my terminal because we're focusing on working with the terminal. In my computer, that's clear. On some computers, that's going to be the CLS command. We can inspect the contents of a text file very simply by typing the word cat and then the file name. So in this case, I'm going to type cat files.txt, and there I see the output that looks like maybe I just ran the ls command. However, I didn't. I just inspected the contents of files.txt. If I inspect new file.txt, it's going to give me nothing in return because there's nothing in that file. However, very quickly, let me just demonstrate the process of putting some text in that file. Here is some text, and then I will save that and then close this out. And then I'm going to rerun cat newfile.txt. Since cat newfile.txt is the very last command I ran, in most terminals, you're going to be able to press the up arrow key to get that command back. I can press the up arrow key again to get the previous command. Then if I want to return to the last command that I did, I can then press down, and now I'm at cat newfile again. And that saves me a lot of typing. And now I can press return. And here we see the contents of that file. The next bingo square we're going to explore right now is how to edit Python in Nano, which is the same as editing a text file in Nano. Python files are just simple text files. Before we start editing a Python file, which I have here, demo.py, let's just look at editing a plain text file with Nano. So to do that, I'm just going to type Nano on my terminal, and then I'm going to type the name of the file that I want to edit. So I want to edit new file.txt. And when I do that, I have my text file on the screen with a very old-fashioned rudimentary editor. I can use my arrow keys to move around. And when I do that, I can move to the very end of the file and I can press return and type, here is some more text. Hello all! Exclamation point. I can type whatever I want. Now, when I'm ready to save this file, I'm going to use the Control keyboard key and then one of the letters from the keyboard. You can see this menu down here in Nano. This tells you how you can navigate files and also navigate the Nano text editing program. You can write the file out, you can read a file, and you can do a variety of other items here, including exit, for example. Let's try Control O. So this up caret symbol is short for Control O. So let's just press Control O, and that gives me the option to save the file. So I'm going to write that file out to this name. Now, if I wanted to, I could change the name just by editing the file name. I don't want to do that. So I'm just going to press return here, and now I've saved the file. The file is updated with this new additional text. I can press Control Exit to get out of here. We can inspect the results by saying cat new file.txt and pressing return, and now we see the updated text for that file. I promised you we would have an opportunity to edit a Python file. Let's do that now. So I'm going to clear my screen. I'm going to say nano demo.py. Then I'm going to open that up, and I'm just going to type the words print hello world. And then I'm going to close my quotation mark and close my parentheses. So I used a single quotation mark here and here. In your future learning journeys, you'll learn when to use single, when to use double. In this case, it happens to be optional. We could have gone with either single or double. I'm just going to use single for this example. I'm going to press Control Exit. Now notice, I'm not going to write the file out first, just to show you what happens when I do exit first. So if I do Control X on my keyboard, it's going to ask me, am I sure I want to do this? If I answer no, I'm going to destroy the changes. And it's a tricky question. It's asking me, do I want to save the modified file to the buffer? I actually want to save my modified file. So I'm going to answer Y here, and then it's going to ask me to name the file. It's going to suggest the name if there already is one. At this point, I can just accept the suggested file name, demo.py, and press return, and now we are back at our terminal. The next square on our bingo card is going to be run a Python file written in Nano. Back over here at the terminal, you can see that I've created the demo.py file. Before you run a Python file, you should always inspect the file, or you should have a very high level of confidence in who created that file and for what purpose. In our case, we can inspect this file by typing cat demo.py in order to see what the code is. And then we see here that the code is very simple. print hello world. Based on our review of this file, we know that it is safe to run, so I'm going to type python demo.py, and when I do that, we see that Python has printed for us the words hello world. For some of you, this is one of the first computer programs you've ever written. Congratulations! This is how you run a Python file that you've written in Nano. Here, we look to complete the Run Python file written in Nano Part 2 square of our bingo board. For this bingo board square, we're going to start with a brand new empty Python file. So for that, I'm just going to type the word nano with no other information at my terminal to get my terminal editor. And remember how our previous example was print hello world, and we had the option to use single or double quotation marks. Let's zhuzh this up just a little bit by returning our cursor back to the beginning of this line. And before hello world, we're going to print some additional information just to make this a little bit prettier. We're going to print 20 equal signs, which is really just going to give us some kind of a border. So we're going to say equal signs within those quotation marks, and we're going to multiply that by 20. This is going to tell Python to print out 20 equal signs. And then we're going to print an empty line, and then we're going to indent hello world just a little bit, and then we're going to print another empty line afterwards, and then we're going to print another border using the equal signs. Once again, multiply that by 20. Now, remember, I created this Nano file from scratch. It doesn't have a file name, and you can see that up here at the top. It says new buffer, and we have no file out on our desktop that corresponds with this file. So what I can do is I can press Control-O to write out my file name, or I could also just do Control-X, and Nano will give me the option to save my file before exiting. To be safe, I'm first going to press Control-O to get the name of the file that I want to write. This is going to be demo2.py, and then I'm going to press Return. And when I do that, we see the new file on our desktop. Now I can press Control-X to exit out of this. And if I want to verify that the file is there, I can press LS, and there is our demo2 Python file. And then finally, to run this file, I'm just going to say clear to make a clean slate. And then I'll type Python demo2.py, and now we have a prettier version of hello world. The next bingo square we're going to work on is how to explore interactive Python. To do that, return to your terminal or your bash and type the word Python. When you do, you should now have access to the interactive version of Python. In the interactive version of Python, I can use some of the commands that we've already learned when we were creating those Python files. I can just type print hello world, for example, and then it will automatically return hello world for me in this interactive mode. Something else you might find interesting in exploring interactive Python would be the command import this. What the import command does, it is extends your basic functionality of Python. So import this brings for you an output or a printout of a poem called The Zen of Python by Tim Peters. I recommend you read The Zen of Python. The next item we should explore in interactive Python would be just to use Python as a fancy calculator. So I could say 100 times 100 to give me 10,000. But what if I want the square root of 10,000? Well, I have to, again, extend the functionality of Python. So what I'm going to do is I'm going to say import math. And when I import math, now I'm extending the functionality of Python to give me more powerful mathematical operations. So for example, now I can say math.sqrt, open parentheses, 10,000, and then when I press return, we get back the correct result. The square root of 10,000 is going to be 100. Math also gives me a convenient way to reference common mathematical constants. For example, here I can represent pi. Most Python syntax is highly intuitive, especially at the beginner level. I recommend that you explore Python. Just use your intuition here at the interactive prompt in order to discover for yourself what you can do with Python. We already know we can multiply 100 times 100. How can you add numbers? How can you divide numbers? What happens if you use parentheses around numbers in order to enforce a special order of operations? How will that affect your results? Once again, just have fun. It's really hard to break anything. Don't be afraid of making a guess. The more you explore, the more you become familiar, the more you interact, and the more you test things out, the faster and better you will learn. Here we look at the bingo square, install a package with pip. By now, you know that you can extend the functionality of Python with the import command or the import statement. For example, in Python, you can import math in order to find the square root of any number. Math.sqrt 100 is going to give us 10 as expected. Now to exit out of Python and then clear my terminal again, I'm going to type pip install pyfiglet. Now what does that do for us? That's going to bring a library to my computer. It's going to install a library to my computer that didn't automatically ship or distribute with Python. The math library automatically ships and distributes with Python, but pyfiglet does not. So I will now press return and we'll see the installation information for that package. Now I can clear again my terminal and then go back into Python. Now that I'm in Python, instead of importing math, I'm going to import pyfiglet. And once I've imported pyfiglet, now I can use it in my interactive environment. The command I'm going to use is going to use the print command in Python, print, open parentheses, and then passing into these open parentheses for the print statement, I'm going to use pyfiglet.figlet_format, and then I'm going to give a text string. Here, I have to open another pair of parentheses. I have to open a quotation mark. I could use single or double quotation marks here. Then I have to close the quotation mark to close that string, close this parenthesis to match this opening parenthesis, and then close this parenthesis to match this opening parenthesis. And when I press return, we get a pretty output that shows hello data. Now this hello data output would not have been available with the base Python. In other words, pyfiglet did not ship or distribute with the version of Anaconda that we installed. It doesn't install or distribute with most versions of Python. This is a demonstration of how you can install new functionality for Python using the pip command. Your next question might just be, where can I go to find more information about other libraries? I recommend doing a Google search for yourself, see what you find. Here we have the trending Python libraries on GitHub. Another place you might look is the R Python subreddit. Have fun with this. See what you can find for yourself in order to explore Python on your own. Here we look at writing a Python function on this bingo card. To start exploring how we might create a function of our own in Python, I've created and displayed a new file called demo3a.py. So here you see that file name, and then I use the cat command to display the contents of the file to my terminal. Here we see some code which is going to collect the user's name. So when this code is activated, the code will first ask the user for their name. Then it will print that border that we learned to create in other bingo squares. It's also going to create a border at the end of the output that we learned to create in other bingo squares. And then we use a new version of our print hello line. So here we're using a special kind of string called an F string. And when you put an F in front of a Python string, that tells Python that you can then use these squiggly brackets to insert information from other portions of your program. So we're going to insert the information that we collected from the user here into the string that says hello. To demonstrate that, I'll just clear my terminal and then I'll say Python demo3a.py. And when I do this, it's first going to ask me my name. I will give a name, say Mickey. And then when I press return, it says, hello, Mickey. If I run that same command again and I give my actual name, we get different output. It'll say, hello, Adam. We're going to convert this code into a function in our interactive environment. So once again, I'll clear away my terminal output. I'll go into the interactive environment by typing Python and pressing return. And now we're going to define our function. So to define a function, use the def keyword. We're just going to name the function. It's just going to be the say hello function. And then we're going to open the parentheses and close the parentheses. We won't use the parentheses for this function. That would be for more advanced functions. And then we have to add a colon here. Now this colon is very important. After that, we can press return and indent 4 times. So I indent my cursor 4 times. Now we have to collect the user's name. So we're going to create a variable called user_name, and we're just going to set that equal to input, open parentheses, what is your name? Question mark, and then close the quotation mark, close the parentheses, press return, and then I'm going to give 4 more spaces here. And now I will add my border. So print =, 20 times. After that, I'm going to add an empty line. After that, I'm actually going to print the actual message. So to do that, I use an F string. An F string is a special kind of string where we put an F in front of the string. The F in front of the string lets Python once again know that we're going to pass some information into this string. So we're just going to say hello, and then open squiggly, user_name, close squiggly, exclamation point, close quotation mark, close parenthesis. This close parenthesis closes that one. This close quotation mark closes that one. Once again, the F reminds Python that we're going to give information to this string from another portion of our program. So I'll press return, 4 more spaces here to give the empty line. Then I'm going to give 4 more spaces here, and I'm going to say print =, times 20, close parentheses, return, return. Now I've defined this function called say hello. If I want to call that function, I can now print say hello in the terminal, and then use open and close parentheses and press return. As expected, Python will now ask for our name. I'll put Mandy here, and I'll press return, and we get back hello, Mandy. I can use the up arrow key again in order to get back to say hello, press return, and I can give a new name here, and we get back hello, Sam. So here we have defined our own Python function. The next bingo board square we look at is how to open a Jupyter Notebook. A Jupyter Notebook is one more way you can interact with Python. I've showed you how to interact with Python at the command prompt. As you will see, Jupyter Notebooks tend to be a more convenient way to interact with Python. Here I am at my terminal. By now, you recognize this as your bash, your terminal, perhaps your Anaconda prompt. I'm also in my desktop location, and I can see that because my terminal is telling me that I'm in my desktop location. Before I start Jupyter Notebooks, I want to navigate back to my user home directory. In order to get to your user home directory, it's simple. Type cd /till. Cd /till is a shortcut, a universal shortcut to take you back to your user home directory on just about any computer. Once you are confident that you are now at your user home directory, you want to type Jupyter Notebook and then press return. When you do that, you're going to see some output on the screen, and also eventually you're going to have a new browser window available to you. This browser window may look fairly familiar. There's a file menu, just like many software applications, a view menu, a setting menus. There's a help menu also. You can also see files on your computer. You could navigate, for example, to your Documents folder or your Desktop folder. Let me navigate to my Desktop folder now. When you do that, we see the Miscellaneous folder, which is indeed a folder on my desktop. We see the New folder, indeed a folder on my desktop. We see Python files that we had been working with. We can open any of these Python files by right-clicking on them and saying Open with Editor. And when we do that, now we have the Python file that we created. So here's demo3a.py. I can copy this code. I'm going to highlight it, press Control-C or Command-C. And now I want to go File, New, Notebook. And here is where we start looking at working with Jupyter Notebooks. When you first start a Jupyter Notebook, it's going to ask you your kernel. If you've installed everything correctly, you can choose Python 3 for your kernel. You have the option to install other kernels, but for now, we're just going to keep with the Python 3. Then you will say select. Now I'm going to paste that code into my cell here. This is called a code cell. And a code cell in a notebook allows you to put Python code and then work with that Python code. Now, just as this code worked for us at the terminal and in the interactive setting, we can now run this code by having our cursor located in the code cell and pressing the run button located up here. So I'll press run, and now, just as before, it's asking me for my name. So here I can put Dane and then press return, and there we have the expected output. Hello, Dane. A nice feature of a Jupyter Notebook is I can start another code cell. And just as we imported additional functionality before, such as import math, I can now import math here, and then I can also evaluate math.sqrt100 to get the square root of 100. If you learned a little bit about math before, I might say 100 plus 100 here, and then multiply that by 2. And now all I have to do is run this because this mathematical expression is acceptable Python code. Just as you could do that in the interactive environment, you can do it here in a notebook and see the result. If you're following along with these videos and orders, you might remember the PyFiglet package that we added and installed and also demonstrated earlier. Just as if we were in the interactive terminal Python environment, we can use that code here as well. Running this code, once again, we see the nice, pretty hello data output from PyFiglet. Here, we look at closing out 2 of these bingo squares. We're going to close out creating a GitHub account and cloning a GitHub repo. If you're following along, we haven't forgotten about the GitHub squares. These squares get a little bit more interesting once you have already installed GitHub. Creating a GitHub account is relatively straightforward. Simply head on over in your favorite web browser to github.com. Then you can sign up on the home page, or you can also click the sign up button here. When you click the sign up button, GitHub is going to ask you for some information, email, password, username. It's going to give you some on-screen instructions. It's going to have you verify that email and you'll be done. Just make sure you remember the email, password, and username you use for this profile. This is a profile that future employers and colleagues might see. I recommend choosing a professional, easily recognizable username associated with who you are. Here we are on a Mac terminal. If you want to install Git on a Mac terminal, you might just start by checking to see if it's already there by typing git space dash dash version. If you see a version number for Git, it means you've already installed Git. If not, that means you have to install it. One of the easiest ways to install Git on the computer is to install the Xcode. To do that, type XCODE, no space, and a dash, and then type select, and then give a space, and now give dash dash install. If I do this on my computer, it shows that I've already done the install. You will see slightly different output. And then once you have checked again that you have Git installed, you know you are ready to go. To install Git on your Windows computer, head on over to gitforwindows.org. That's gitforwindows.org. You'll find this page or a page similar, and then go to the download option. After your download finishes, click Show All Downloads, and then you can double-click on the installer. Once you double-click on the installer, you're probably going to get asked if you want to allow the app to make changes to your device. You're going to say yes to this, and then you'll follow the on-screen instructions. All of the default choices here are going to be helpful. I recommend perhaps adding Git to your desktop. Click Next. You'll probably see an option like this one. And once again, I recommend just taking the recommended actions. Once you have finished choosing all of the options, click the install button. At this point, you can close your browser. You will likely have to do a restart and then return to your Anaconda prompt. I'm going to choose the start menu, and I've already pinned the Anaconda prompt to this computer. And to verify installation, type git version. Once you see a version number, you know you're ready to move on to the next steps. Finally, back over to the Mac computer, I want to show you how to clone a GitHub repo. Cloning a GitHub repo means copying a repository from GitHub to your local computer. If you don't know what a repository is basically a project that a software developer has developed and made available for others to clone or copy to their computer. To do this, we're going to clone our project to our desktop. So I'm going to type cd /desktop and press tab and press return. That's a topic we've covered in other bingo squares. And now that we're on the desktop, we're going to type git clone. And the very next thing we need to give is the location of our GitHub repository. We're going to give a web address to the online location for that repository. To get that repository, open up a web browser and type GitHub Adam Ross Nelson Confident Data Science and press return. The first result is going to be the repository that goes along with the data science book that I wrote. You can read about that book here, but what we need in order to clone this repository is the online location. To do that, click on the green code button, scroll down, and use this copy to clipboard icon here. Click on that. Now you can close away your browser and just paste in the URL that you copied to your clipboard. Now press return, and that's going to copy and bring the repository for that book to this computer. And once again, indeed, you can see the file here that corresponds with the repository that we just cloned. The next bingo square we're going to knock out is use Pandas to read a CSV file. And we're also going to do make a simple plot. We're going to use the CSVs that we also just got done cloning. Now, we are going to use the GitHub repo that, if you're following along, we just got cloned to our desktop. To see that, you can type ls in your terminal, and you can see the folder for the GitHub repo called Confident that we just cloned via Git. To explore the Confident folder, you can change into that folder and then use ls to explore. See here a data folder. Let's change to that directory and then see what data sets there are available. We have a data set on bank complaints. We have a data set on miles per gallon. We also have a data set about chapter 6. We'll take a look in Jupyter Notebooks. Here we are in Jupyter Notebooks. This is a topic, remember, that we covered in another bingo square. We're going to use Jupyter Notebooks in order to explore the CSV file and use Pandas to open that CSV file. To do that, let's create a notebook on our desktop. Just double-click on Desktop there to find yourself in the desktop, where you see the Confident folder. Let's create a new notebook by choosing New and Notebook, and then select Python 3. Let's just call this load CSV and click rename here in order to change the name of your notebook file. Now, just as before on some of the other bingo squares, we used the import statement to extend the functionality of Python. We're going to import Pandas as PD. Pandas is a library that lets us work with tabulated data, the kind of data you find in a CSV file. So type import pandas as PD, run that cell. You shouldn't have an error if you installed the full Anaconda distribution of Python. And then we're going to load a data file located in our Confident folder here. Let's explore that just a little bit further. We're currently working in our desktop folder, and we want to load a data file that's in the subfolder called Confident, and then another subfolder called Data. We're actually going to open this file here, confident_ch6.csv. This is a file that goes along with chapter 6 of the Confident Data Science book that I wrote. If you want, you can actually click on that, choose Open with CSV Viewer, and then you have an option to see the data that we're about to load into our Pandas data frame. Back on over to our notebook where we've already imported Pandas as PD. We're going to set df equal to pd.read_CSV open parentheses. Then we're going to use single quotation mark. We could use single or double here, but in this case, we're going to use single quotation mark. We have to specify the name of the folder where we know the data are located. So first we look in the Confident folder, then we saw the subfolder data, and then we want to open confident_chapter6.csv. We're going to close the quotation mark, close the parentheses, and then run that cell. Once we do, now we know we have loaded that data into this variable, into this object called a data frame. Now to inspect that data, all I have to do is evaluate it by typing df here in an empty code cell and then running that. Now we see the data that we loaded from the CSV file. It's not quite easy to see. I'm going to press Command- on my keyboard so I can see the whole data frame all at once. I also promised you we would close out the square for making a simple data visualization. To do that, we're going to load another data set, and we're just going to call it the bank data set. And we're going to set that equal to pd.read_CSV, open parentheses, open quotation mark, confident/data/complaints bank.csv. And then when I run this cell, we're going to load that data frame into this bank. Now, if we want to look at just a simple sample, just a random set of 4 observations, let's say from that data, we can type bank.sample, open parentheses, 4, close parentheses. Run that, and now we have an excerpt of our data. This is data, it's fictional data, that includes a variety of customer complaints from bank customers. We know what product the complaint was related to. We know what language the complaint was in. We know how the customer made the complaint, whether it was by telephone or some other options as well. We know, again, this is fictional data. We know the name of the complainant. We know their address, and we have some other information about these data. For our simple data visualization, let's visualize the NPS response rate by the type of product. This is going to give us an idea as to how well each product is performing. A higher NPS rate, or an NPS response, which stands for Net Promoter Score, a classic customer service metric, is going to tell us that that product is more favorable among customers. A lower score is going to tell us that it's less favorable among customers. So actually, let's also just look at the mean NPS response rate by product before we visualize it. So to do that, I'm going to say bank, open square bracket again, and then I'm going to open a quotation mark. And then I'm going to give the column name product here, and then I'm going to close that quotation mark, and I'm going to give a comma, and then I'm going to open my quotation mark again, and I'm going to put NPS response for the column title of the NPS response. And then I'm going to close that bracket, and then I'm going to close that bracket again. Let's just double check our work because everything here is case sensitive. So I want to make sure that I have product correct and I have NPS response correct. Turns out I need capital P and I need capital R. So let's just double check that we've correctly specified our column names. Now the next step of our code is going to be .group by, and we're going to group by product. So again, I'm going to type product here, and then I want to look at the mean NPS responses by each product. So at this point, I'll just say .mean, open parentheses, close parentheses, and then run this code. And now we see that the ATM NPS response rate averaged is 6.3. And then we see that the other product is much lower and the web branch is quite a bit lower as well. Now, let's visualize the NPS response by product type. So to do that, we're going to extend functionality again. And we typically put all of our import statements at the top of a notebook, but in this example, I'm just going to import Seaborn as SNS on the fly, and then I'm going to run this code here. And now we have access to the Seaborn library, which is a data visualization library. To visualize this data, we're going to utilize a box plot. To create a box plot, all we have to do is type sns.boxplot and then open parentheses and specify the data, which is bank data. We're going to specify our x variable is going to equal NPS response. And then we're going to specify our y variable as product. And we also have to give one more argument here called orient, and I'm just going to set that to H. Then I close my parentheses, close my quotation marks, and now press run for that cell, and we have a box plot which shows us roughly a summary of our NPS responses by product name. Here you can see that the median NPS score for all three products is right at about 7. However, the other category and the credit card category and the web branch category seem to have many responses that are very low, quite a bit lower than the mean or median. Conversely, bill pay, checking, and ATM also have median NPS scores at about 7, but they tend to be doing a little bit better, especially bill pay. Bill pay seems to have more positive NPS scores. If you're following along, congratulations, you've covered a lot of ground. In this segment, we're going to look at making a simple data frame. We're going to do that in Jupyter Notebooks. For this demonstration, here I am at my desktop in Jupyter Notebooks. I'm going to create a new notebook here, and we're going to call it Simple DF as an example file name. Now, we're going to import Pandas as PD. This is going to extend the functionality of Python to give us access to the Pandas library. Now, to create our own simple data set, we're going to use a special technique, a special syntax, a special data type in Python known as a dictionary. You have two key items in a dictionary. First, you have your values. Values are actually going to be the columns in your data set. And then you're also going to have keys. Keys are going to be the column names. Let me show you what that means. I'm going to create a dictionary called my data, and it's going to have one key and one value. The first key is going to be called my_key, and then I'm going to set that equal to some specific data. Doesn't really matter at this point for our demonstration purposes. I want to show you how a Python dictionary works. Now, when I run this cell, I've defined my data. I can copy my data into a new cell by putting this on the clipboard and then pasting it here. Now, if I want to access this value. I can use the dictionary key, my key. So if I do the square bracket, open parentheses, my underscore key, we're going to see the result, some specific data. So let's make this data more interesting. I'm going to delete this cell here. I'm going to delete the first key and also the first value. I'm going to remove that from my dictionary. So to create your dictionary, you might just look around your neighborhood and see what kind of houses there are. So we're going to have a column for house number. We're going to then create a list of house numbers. So I'll say we have a house number at 431, we have a house number at 433, and a house number at 435, and a house number at 437. Then we also know in our data set, we're going to need a column for the name of the people at that house. So I'm going to put family name as the column name. So let's go with a family named the Dawson family. Let's also go with a family named the Washington family. The third family at house number 435 is going to be named the Andrews family. And then lastly, the family at house number 437 is going to be named the Leaf family. After that, let's also include the type of house in our data. So we'll call the column for house type, and then we'll just create a type of houses. So we're going to say a 3-story house. That's a big house. But this one is going to be 2 stories. This one is going to be a 2-story. This one is also going to be a 2-story. And then finally, the Leaf family in house number 437, let's say we don't know. I'm just going to put unknown there for our data. Let's create one more column for our data. Let's also create a column for the year of manufacture. So the year that the house was manufactured. To do that, we create again our column name here. So house number 431 was built in 1950. House number 433 was built in 1955. House number 437 was built in 1954, and house number 437 was built in 1930. Now I will run this code cell once again to create my Python dictionary. And if I want to get a list of the names of folks living on my street, I can once again use that Python dictionary to reveal the list of folks who live on my street just by referencing the key for that column. And when I run this cell, we do, as expected, see the family names. But we want to create a data frame. So what we're going to do is we're going to pass this myData object into the data frame method from Pandas. So to do that, I'm going to create a new variable called DataFrame. I'm going to set that equal to pd.DataFrame. The D and the F need to be capital here. Open parentheses, my_data, close parentheses. I run that. We don't see any output, and that's okay because we haven't done anything with it. All we did is we stored it there. Now, if we want to review the results of our work, we can type df in this next code cell, run that, and there we have our own data frame that we created on the fly. The next bingo board square we're going to knock out is going to be use a Python loop. Oh no. Imagine that you just created a data set, but there was a data entry error. For some reason, all of the years for your houses in this fictional data set that we created when we were knocking out another square on the bingo board, all of the years were off by 1 decade. In other words, this should have been 1940, that should have been 1945, this should have been 1944, and this should have been 1920. One option would be to go back up here and just re-specify the data. And that would work, but what if we had hundreds or thousands or maybe millions of records, and we just knew that there was a systematic error and we needed to correct that error? So we can use a for loop to fix this for us. Side note, this isn't necessarily the most efficient approach to fixing this data, but it's a good example of how to use a for loop, and it does solve the problem. So let's go ahead and just take a look at this option. We're going to first specify a new column by saying new_call equals empty list. Then we're going to say for year in df year colon. Now this is the syntax that we've looked at in some of the other squares on this bingo board game. This is the syntax that works for getting the column in a Python dictionary, or also it happens to be the same syntax for getting a column in a Pandas data frame. Now, this for syntax is what's going to let us loop through all of those years and fix them one by one. So each time we go through this for loop, we're going to append to this currently empty list the corrected value. So to do that, I'm going to say new underscore column dot append, and then inside the append, I'm going to say year minus 10, because remember, this was supposed to be 1940, 1945, 1944, and 1920. When I do that and then evaluate the results of new call, we will indeed see the corrected data. I can run this cell here, and now I have this corrected data. So we've used a for loop. Congratulations. Now, if we want to actually replace this column, we're going to specify df year equals new underscore call. And when I run this, we're not going to see any output because all we did was assign this data from new call into the data frames column for year. And now if we evaluate data frame again by pressing run after typing df in this code cell, we see the corrected data. The next square to mark out on this bingo board is going to be run code from GitHub. So we're going to clone a GitHub repository, and then we're going to run code from that repository. So here I am over in the Mac terminal in the home user directory. I want to clone a GitHub repo to my desktop. So to do that, I'll just type cd space desktop in order to navigate over to the desktop. And now when I clone new items, I'm going to be able to see the results over here on my actual desktop. To clone the repository, we'll go ahead and type git clone, and then we'll type the location of the repository. I'm just going to give you this location because it's a little bit hard to find on your own. It's going to be https://github.com/dimikara/A for adventure _game G.git. Run that code, and then you're going to have the adventure game here on your desktop. You can change directories into that adventure game with the cd command once again, and then use ls to inspect your files. We have adventure_game.py, adventure_game.gif. There's a license, a README file, and there's a screenshot as well here. Let's just inspect this Python file. Remember how we do that? cat adventure game adventure_game.py, and then press return. And this is going to show us all of the code from that Python file and game. This looks safe, so we can run it. Once again, never run Python code unless you are fully confident of the source of the file and the purpose of the file, or you've inspected the code yourself. So to play this game, we're just going to type at our command prompt the words Python adventuregame.py. And when we press return, we find ourselves standing under a light post. There is a door just across the street. You are there waiting for hours. Suddenly the door opens, and an ugly tall guy makes his appearance. Your first reaction is to go directly to him, but then you see better. He has a gun at his right hand while he drags a young girl with him. Enter 1 if you are brave enough to try your luck with him. Enter 2 to stay hidden. What do you want to do? Here, I'll choose number 2 and press return. After that, the story will continue. Let's see if you chose wisely. You run to your car. You pick up your gun and use your phone to call 911. You then go back to confront the abuser. The girl was saved unharmed. You killed the bad guy, but he had a partner that fled unnoticed. The end. Do you want to play again? In this case, I'm going to say no and press return. Congratulations. If you're following along, by now you're almost done with the bingo card. You have successfully downloaded code or cloned code from the GitHub repository and run it on your local computer. The final bingo square to close is going to be Explore Markdown Tutorials. This regards a feature of Jupyter Notebooks that I haven't shown you yet. Over here in our Jupyter Notebook, we're going to start a new notebook. I'm going to say select Python 3, and we're just going to call this Markdown Demo, and I'll rename that. And then the item that I haven't demonstrated for you in Jupyter Notebooks is you have the ability to create other types of cells. So far, we have only worked with code cells. We can import additional libraries to expand the functionality of Python. In order to do more advanced topics, we can use Pandas to look at tabular data. We can use Seaborn to create data visualizations. But what if we want to add additional narrative to our notebook? So I created a new cell here above my import, and this new cell, I'm going to change its type to Markdown. Markdown is a special syntax that lets me give rich formatting. So this is going to be the main title. After that, I'm going to give a description of the notebook. This notebook demos Python. I can also create a bulleted list here. First, we imported math, then we found the square root of 100. Now, if I run this cell, it will render as rich text, making the notebook easier and nicer to read. Gives me a way to talk about my code, explain what my code is doing. If I have a data visualization or a table, I can explain or narrate or discuss that data visualization or table. There are other formatting options. For example, if I add a backtick here and a backtick here, and then run this code, you can see that the font changed for that math. It's a common practice to do this sort of vintage looking font for items that you would also find in code. This allows you to mix actual narrative with what we call inline code examples. There's a tutorial to teach you how to write better Markdown or Markdown more completely. Go to the Help menu in Jupyter Notebooks and then choose Markdown Reference. Once you choose Markdown Reference, you're going to have a collection of syntax options that can help you write better Markdown. Also, you can complete the Markdown tutorial. There's a series of several lessons here that will walk you through the process of writing Markdown code. Congratulations! Now that we've also knocked out this very last square, you have finished the bingo card game. Thank you so much for participating. Let me know what you thought of this. I hope you had fun, and I hope you learned at least a little bit of something, and I look forward to seeing you in another video.